You might come across this in your next exam. Here is exactly how to solve it. 1 gram of a mixture of calcium carbonate and calcium oxide. Now, I want to draw your attention to something. Whenever you heat calcium carbonate, is written as this CaCO3. Never forget, this is calcium carbonate. Whenever you heat calcium carbonate, it decomposes to give you calcium oxide CaO and carbon 4 oxide CO2. This is what you would get. Now, the question here is a bit complex, meaning that the question says 1 gram of a mixture of calcium carbonate and calcium oxide, meaning this is what they mean: a mixture of calcium carbonate CaCO3 plus and calcium oxide, right, CaO. You have these together. Now, do not forget that this calcium oxide, if we decompose the calcium carbonate, which is what we did here, would get it here. Do you follow? Would get it. So the mixture contains calcium carbonate and calcium oxide, but we can get calcium oxide from, when we heat calcium carbonate, we can get calcium oxide, and we also get carbon 4 oxide, which is this as written here. So I would continue with the question now. 1 gram of a mixture of calcium carbonate and calcium oxide. So the both of them here is 1 gram. Mixture, the mixture liberated 0.33 grams of carbon 4 oxide. 0.33 grams of carbon 4 oxide. So I'm just going to start solving. So carbon 4 oxide CO2 was given to be 0.33 grams, right? 0.33 grams of carbon 4 oxide. On strong heating, the percentage of calcium oxide in the mixture is dash. So the first thing we need to know now, since we can get calcium oxide and another calcium oxide from, so since we are given calcium oxide 1 in our mixture, and we can also get calcium oxide 2 when we heat calcium carbonate, which is this. When we heat this calcium carbonate, we need to solve for the mass of calcium carbonate, and in doing that, we'll use Sam's relation. But keep in mind that the atomic mass of calcium the molar mass of calcium carbonate is actually 100 grams, and that of carbon 4 oxide CO2 is 44 grams. And from our equation, we're given carbon 4 oxide. The mass of carbon 4 oxide based on this equation is 0.33 grams, which is this. Now the standard mass of it is 44 grams, and the standard mass of calcium trioxocarbonate 4 is 100 grams. So I'm just going to manage this place. Given times what we want, what we know from what was given, and it becomes given is 0.33 times what we want is 100 over what do we know from what is given is 40. So going further, I would punch my calculator here. You could do the same. 0.33 times 100 and would arrive at 33 divided by 40. 33 divided by 40 0.33 times 100 divided by 44, sorry, my bad. supposed to be 44, not 40. 44 here, not 40. So 33 divided by 44 would get 0.75. And so the mass of calcium carbonate CaCO3 is 0.75 grams. And next, to get the mass of calcium oxide, which is our major concern in this equation, to get the mass of calcium oxide in that mixture, would need to say, don't forget that the mixture was 1 gram minus 0.75, which is actually the mass of calcium carbonate. We just solved it here now, equals, if you minus this, you get 0.25. This is now the mass of 0.25 grams. This is now the mass of calcium oxide in the mixture. This is the mass of calcium oxide in the mixture. And lastly, we are asked to calculate the percentage of calcium oxide in the mixture. So CaO percentage in the mixture would be 0.25, which is the mass over 1, which is the total mass of the mixture. The 1 is from here, the total mass of the mixture, times 100, and this will give you 25%. So the percentage of calcium oxide in the entire mixture is 25%. Would you like to solve similar questions as this? Click on the link in the description box. And if you do not get this at the first time, you could actually rewind the video again.